Hello everyone, welcome back to my YouTube channel. So now I'm going to solve question number 3 of weekly contest 491 minimum bitwise or from grid. So in this problem you are given a 2D integer array grid of size m into n, and you must select exactly one integer from each row of the grid, and we have to return an integer denoting the minimum possible bitwise or of the selected integers from each row. So here if you see this example number 1, so this is a grid given to us. So it's like this 1 and 5, then we have 2, and here we have 4. This is the grid given to us. Now from each row you need to select exactly one integer, and we have to return an integer denoting the minimum possible bitwise or of the selected integers from each row. So one way is like this: you if you do 1 or 2, or you can do 1 or 4 here, or you can do 5 or 2, or you can do 5 or 4. So here if you do 1 or with the 2, so what is the result you are going to get? So 1 is like this and 2 is like this, so you are going to get 3. And if you do 1 or with 4, so 4 you write it like this now, and you are going to get this bit value is 1, this bit value is 2, this bit value is 4, so you are going to get 5. What is 5 or 2? So 5, how you write in binary form like this, and or with the 2 you write it like this, so you are going to get 7. And 5 or 4, so 5 you write it like this, 4 you write like this, and the value is 5 here. Clear this part? So in OR operation, if you notice, if we set any bit here, so in the result we will always see 1. If we set any bit in the result we will always see 1. Here it is 1, so 1. Here it is 1, 1. So what I'm saying here, that in OR operation, so if you are doing the OR of multiple numbers, let's say x, y, z, a, b, c, multiple numbers, you are doing the OR operation, and if in any of these numbers, if at any place you see 1, so in the final result you will definitely see 1, because using OR operation it is not possible to unset any bit. So if a bit is set at any one place, it will definitely be there in the result as well. So here if you see, uh, let's take a few numbers now. Let's take 2, 3 and 4. How you write 2 in binary form? Like this. How you write 3 in binary form? Like this. How you write 4 in binary form? Like this. So if you do the OR operation among all these, so you will find that here if anywhere you see 1, so it will be here. If anywhere you see 1, it will be here. If anywhere you see 1, it will be here, like this. Clear? So among this, if you see this now, so here minimum is 3 now, so that's why output is 3. All right, this is clear. So you are doing the OR of this and this. Clear this part? So choose 1 from the first row and 2 from the second row. The bitwise OR is this. All right, so here I hope that this part is clear. 2 or 3 or 4. So if you do OR of 2 or 3 individually, you are going to get this. And if you do the OR of 3 and 4, you are going to get this. So see, you are going to get 7. All right. Now here, this thing is clear. But now how we are going to know that we have to choose this 1 and 2 from here? We can try. Can we try all different possibilities? No, it is not possible. It will give you time limit exceed error because of this, the constants. So m is from 1 to grid dot length, m is equal to grid dot length, and it is up to 10 per 5, and n is also of same size, and here it is given that m into n is this 10 per 5, but you can't try all these combinations. That will be little bit hectic, and that will definitely give you the time limit exceed issue. And here grid ij value is from 1 to 10 per 5. All right, so it is saying that the numbers in the cells, they have value up to 10 per 5. So 10 per 5 means 1 2 3 4 5. So actually when I am going to write it in binary form, So I can say that I can cover it in this range. So this value is going to be less than this 2 power 17. Why I'm saying that? So here if you see in binary form, this bit value is 1, this bit value is 2, this bit value is 4, this bit value is 8, 16, 32. So all these are in power of 2, right? This is 2 power 0, this is 2 power 1, this is 2 power 2, this is 2 power 3, this is 2 power 4, this is 2 power 5. So I am saying you are dealing with here bits only, na? You are dealing with bits only, right? So here you have different bit set. So I'm saying that if you have all the 17 bits set up to 2 power 17, so all the bits are set, let's say. Okay, all the bits are set. So 2 power 17 actually, here what I'm going to do in code, I'm going to do it like this. I need here, if you see one thing here, 10. Okay, I'm giving you one smaller example, 10. So 10 I can represent it like this. This value is always going to be less than 2 power 4. Okay, I'm just taking smaller example, but tell me 10 is smaller than this 2 power 3. No, no, but it is true. Okay, it is true. 10 I can always represent like this. So that's what I'm saying now, that this value is always going to be less than this. So here what we need 4 bits at least to show this value we need at least 4 bits. So this bit value is 1, this bit value is 2, this bit value is 4, this bit value is 8. So 10 you write it like this, na? 1 uh 1 here, and then 0 0 here. This is how you write 10. Okay, but here if you see, you are needing the 4 bits. You are needing the 4 bits to represent this 10. Okay, but here what I will do, what I will do here, I want to treat all of these are as 111 initially. I want to treat them as 111 initially. This is what I'm going to consider my initial result. Okay, I'm going to consider this as my initial result. So how I'm going to get this 1111? So here if you see, uh this is nothing but 2 power 0, this is but 2 power 1, this is but 2 power 2, this is but 2 power 3. But here I'm saying the 2 power 4 I'm writing, na? 2 power 4 I'm writing here. If you see, I'm taking one more actually. This is nothing but 2 power 4. But here actually we don't need anything, right? Here we don't need anything. Here it is 0, here it is 0. But what you are doing here, you are taking all these ones. So can I write it like this? 2 power 4 minus 1. What is this 2 power 4 minus 1? So if when in some power of 2 I do minus 1, so I will get what? 15. So 15, this is nothing but 15 only, na? If I need all these bits to be set, this is nothing but 2 power 3 minus 1. 2 power 3 is nothing but 8. So 8 is like this. So from 8 if I subtract 1, I will get 7, and with 7 I am going to get all the set bits here. So now what is the purpose of this one? Why I'm taking all these as set bits here? This is your next question. Why I'm taking the set bits here, right? So this is same thing actually I'm planning to do here. This I can represent it like this. It is less than 2 power 17. So what I will do, initially I will take 1 and I will just do the left shift of this 1 by 17 times, and from this I will subtract 1. From this I will subtract 1 so that I get all ones. That's what, na? Here if you see what I'm doing, 1 I'm doing the left shift, small example, 1 I'm doing the left shift by 3 times, and then 1. So that simply means in how you write 1 initially here, right? Now if you left shift this 3 times, 1 time, second time, third time, so you are going to get this. And now if from this is nothing but 8, from this if you subtract 1 you are going to get 7, and with 7 nothing but 1 1 1, 3 ones. So I hope that you are clear with this small example so that you can understand this. That's the only purpose I'm showing it like this, right? Okay, so here what I'm doing, I'm setting all the 17 to 17 these bit positions to 1 1 initially. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17, all that stuff. All right, now this is done. Now I'm only dealing with these 17 bits only, actually these 17 bits only I'm dealing with. Now here, see, if I have, let's take this example, 3 5 and 6 4. So I have something like this, 3 5 6 4. So here in this case, actually I don't need to consider this big example, this big, but the values can be big enough here. But here if you see in this grid value, values are very small. All these values, I can say all these values are going to be less than 2 power 3 here in this example. The max value, if you see, it's 6 na? So it is going to be less than this, right? Clear? So I can actually represent all these in these 3-bit positions. 3-bit positions. For simplicity, I'm going to take this example 3564. So let's take this example 3564, and I can represent it in just 3 bits. That's what I'm saying, right? So I will just show you this small example, and this same thing actually you have to write it like this. So instead of showing it for all this, I'm just showing it for just these 3 positions. So in these 3 positions, let's say we have 1 1 1. Now this side is having most significant bit, and this side is having least significant bit. So definitely, since I need to return what? I need to return the minimum possible bitwise OR. Minimum possible bitwise OR. And in bitwise OR, if you see this bit is set anywhere, that simply means in the final result also this bit is set. That's what I told you initially. So if you are doing the bitwise OR of multiple numbers, so if anywhere you see 1, so definitely it will be 1 in the here at this position as well, right? So but here we have to start from here, and we have to check if it is possible that we can make this bit equal to 0. If it is possible, if we can remove this bit, set bit, initially I'm taking all ones here. So that's what I'm going to check. So how you write 3 in binary form? First tell me. 3 in binary form, 1 2 4. 3 you write it like this. How you write 5 in binary form? You write 5 like this. How you write 6 in binary form? You write it like this. How you write 4 in binary form? You write like this. So here this bit I plan to remove. So how I'm going to remove it? So initially your result is nothing but let's say this all set 1 2 4. So result is 7 initially, right? So now in this result I'm going to add this, and I'm going to do the AND operation, and here I will do the negation of 1 left shift bit time. So here what is this bit value? This bit value is 0, 2 power 0 na, 2 power 0. This is 2 power 1. So that I will say this is bit 1. This is bit 1. So, and here I will say this is nothing but your bit 2. Bit 2. This is nothing but 2 power 2. Okay. So here I'm checking this position. Na? So 0 index, 1 index, 2 index, that's what simply I'm saying. So what I'm saying here, just left shift your 1 2 times. 7, and here negation of this. So 1 left shift 2 times. So 0 0 1, 1 time, 2 times. So you are going to get 1 0 0. Clear this part? So here you are getting 7 negation and negation with 1 0 0. And negation means all are going to make opposite of this, right? 0 1 1. And here we have 7. So here 7 is nothing but 1 1 1, and you are doing the AND with 0 1 1. So let's do the AND 0 1 1. So you are doing AND. So this is 0, this is 1. So that simply means this is what I want. I want to make it as 0, and rest all I am saying let's keep it 1 1. That's what my plan is, right? So that's what I'm saying here. Let's unset this. It is 1 initially I'm taking. I have to somehow remove this bit. Okay, so 0 1 1 I'm going to get. So I will do it like this now. I'm getting 0 1 1. Do it like this. That's what I need to do, right? So now this is the mask. Let's say this is my mask value, 0 1 1. So now what I'm going to do, I'm going to check. I'm going to check here if I do the OR operation of this with this. Okay, if I do the OR operation of mask with the number, and if I get the value equal to mask, I'm doing the OR. So in OR, okay, in OR, I'm doing the mask, right? So in mask, if I have this, and if in number I have any additional bit set other than these two, I will get always a bigger value here. I hope that what I'm saying is you are understanding that bigger number. So I'm doing the OR operation of mask with a number, and if in number, if other than these two places, if I see any more one anywhere else, I will always get a bigger value, right? I will always get a bigger value. So here what I'm doing, if mask, and I'm doing the OR with the num, and if the value equal to mask only, if the value equal to mask only, that's the premise, I'm getting the same number. So here if I have 0 0 0, or here if I have 0 0 0 0, then I'm going to get result 0 1 1 only, since I'm doing OR. Here if we have 0 1 0, then also I'm going to get the same result. If here I have 0 1 1, then also I'm going to get the same result. If here I have 0 1 0, also I'm going to get the same result. If here I have 0 1, I will always get the same result. But if in other these two position, if I see 1 here, then I will always get the value which is not equal to mask. So that's what I'm saying. So here in this case, this or this, I'm getting value equal to mask only. Mask or num is equal to mask. Yes, it's true. So in this case, if I choose this, I'm able to remove this bit. Now I have to check from this row also, is it possible? I don't need to check this 5 now, right? So here I move to this 6 and 4. So 6, with this 6, 1 1 0, and we have mask like this. With this, see, I'm not getting value equal to mask. No, with 6 it's not working. With 4 it is working. Let's see. 4 is like this, and 3 is like this. No, this is not working. This is not working. This is not working, right? So here answer is not possible, right? So here if you see in the final result, if you see, we are not considering this 3 as of now. We are not considering this this. We are not able to, what I'm saying here, we are not able to remove this bit. We are not able to remove this bit. We are not able to remove this bit. I have to choose a number from both these places, such that at this place I can make 0. But I'm not able to do that. From here I'm able to do that, but from here if I choose anything else, so I'm always getting 1. So as of now, result is still 7. Result is still 7. Right. Now I will see if I can remove this bit. I will see if I can remove this bit. Now I move to this. So if I plan to remove this bit, so this bit is at 1 position. So 1 left shift by 1 time. So and you have to do the negation, and here the original number 111, the original result as of now. You have to do the end of this. So that is nothing but 1 and negation of 0 1 0, and here if you just opposite everything 1 1 1, and here you opposite everything, so 1 0 1, and if you do the end of this, so you are going to get 1 0 1. So that's it. So 1 0 1 you are getting now. Okay, 1 0 1, that's the my plan. Now I am seeing if I can remove this. All right, again I am going to check this. 3 is like this, and here we have 1 0 1. No. 5 is like this, 1 0 1, and here we have 1 0 1. Mask value is also 1 0 1 now, this time 1 0 1, the new mask value. Yes, it is possible. So now from here I choose this 5. Okay, now I move to this 6. 6 is like this, 1 0 0, 1 1 0, sorry, 6 is like this, and your this 1 0 1 mask value. So again result is not possible with this. Okay, with 4 result is possible. Let's see. Your mask value is 1 0 1, and your 4 value is like this. Yeah, with 4 result is possible, right? So here if you see 5 I'm choosing and 4 I'm choosing, and if I choose these two numbers I'm able to remove this, and definitely I will go with it because this is the most significant bit. So if somehow I am able to make it 0, that's good. So let's choose this. Okay, so I'm going to get 101 now. Okay, 101. So 101 is nothing but the new result. 1 2 4 5 5 result 5 is possible. Max result is 7, so now result 5 is possible. Result 5 is possible with what? With this, if you choose 5 from here and 4 from here, 5 and or 4. So 5 is like this, 1 2 4, 5 is like this, and 4 is like this. See, 5 is possible. Now we have to check some better result na, that may also be possible. Now I have tried to set this as 0. Okay, now see, new result is this 101. So now in this result only you have to try to remove this bit. Okay, that simply means you have to make it 100. So how you do that? So 1, again you have to left shift it 0 time this time, and negation, and here result value. So 101, 1 left shift 0 time, so 001 and 001, and negation of this, and here you have to do the and so it is nothing but 100. So 101 and here 100. So you are going to get what? 100. So that's what I want actually. So now I have to see here if 100 is possible, if this 100 is possible, right? This is not even mask value, if this is possible, right? So just apply this formula 3564, this thing, same thing na, 3564. So 100, with this you are not going to get 100. With this also you are not going to get 0. This also it will not work. You do the or you will get always bigger value than mask. Here you will work, but if in first row itself it's not working na, so why do you need to check further actually with this? Because from every row you need a number with which this result is possible, with this mask value is possible, right? So if you see, the final answer is nothing but 5 here. That's it, 101. So you can apply the same thing, you can apply the same logic here na. Try this, right? Now let's write the code is going to be very very simple for this one. So here int result is equal to, here I told you 1, just do the left shift 17 time, and here you have to subtract 1, because any number in 2 power if you subtract 1, so you are going to get all the set bits. So here why I'm doing this, since grid of I and j value, since grid of I and j value here is always less than equal to 10 to 5, 1 2 3 4 5, this is what given to us, and this value is always going to be less than 2 power 17. So that's the reason I'm doing this. That's it. And here you have to just run one loop, and here we have to start from the most significant bit. So here int bit is equal to 16. Why I'm writing 16? Because bits are starting from 0 position na, 0 to 16, total 17 bits only. So here that's what, don't get confused, bit minus minus, and here first you have to take the mask. So how you take the mask? So we have to just remove the most significant bit in the result as of now. So whatever the result you have, and in this result you have to do the and here you have to do the negation of this, with 1, and here you have to left shift it with bit number of times. So here you are going to try removing this bit, that's what the purpose here. And if it is possible to remove this, from grid, you have to check in the grid and mask these two values you are sending. So this is going to be your updated result, because we are starting from the most significant bit. So if we are able to remove it, let's store it the result, because this is some minimum value than the initial result that I'm taking. It is a max because here all the bits are set, and here you have to simply return result. Code is very simple, that's it. And here you have to just write the method where possible. So it is just going to give true or false na, private boolean and possible and here int grid, and here int mask, and here for you have to just iterate over all the rows one by one. Int row in grid, and in this row first just create one variable boolean found. So if you found any number with which this mask is possible, right? So you have to first iterate over all the elements in this current row. For int num in this current row, and here how you have to check. So here if, and inside this if you have to do this num or with mask, if the value still comes out equal to be mask only, then that simply means that it is possible. So found is equal to true in this case, then you don't need to check the remaining elements in the row, so you have to break it. And once you check the complete complete row, okay, and if you are still not able to found this any one number with which result is possible, this mask is possible, then in that case you have to simply return false from here. You don't need to check further. That's it. And here otherwise you have to simply return true. This is your code, just 25 lines of code. So now let's run it and see if the encoding will try to fix that. So see, all the test cases has been passed. Now let's try to submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. See you guys next video. Thank you. Bye bye.